Yes, myself I am T. Vamsidhar, Assistant Professor in Keele University. I am course coordinator for this Big Data Analytics. So today I am going to explain what is the actual purpose of that Big Data Analytics and why it is that much important for the near future. So as per course concern, the entire CO1 is related to that Introduction to Big Data Analytics, and CO2 is followed by how we have to use that Hadoop concepts. So first I will start with Introduction to Big Data Analytics. Now it's an overview about the Big Data Analytics. See, if you use real world entities, like if you take any kind of application which is very useful to the society in terms of data analytics. So first information is related to that credit card companies, they monitor the purchase. Why the credit card companies, they need to monitor the purchase? Definitely, if a company or a bank need to provide any credit card, first of all, it will check whether a person is eligible for that card or not. So based on that, first of all, it is going to be make it possible whenever we are going to use this kind of big data analytics, we can easily analyze the person's data, financial data, and if he is eligible for that particular credit card or not, it will check. Later, they will issue the credit card if the particular person is eligible. Second, the mobile phone companies, they are going to analyze the calling time. So based on that, they will introduce some recharge plans. So for that purpose, definitely we should use big data analytics. Third important scenario widely used, that is for social networks, data is a primary product here in big data analytics. Day by day, in terms of Facebook posts or in terms of Instagram posts or in terms of any Twitter messages, each and every social media is now widely spread into the world, and it's created a big data. It's created very huge data. So where we have to store this data? Obviously in data centers. But how we can able to manage it? How we can able to analyze it? So that is the concept of this social networking platform. Also they need to analyze the big data. So these are the three applications widely used to go for this big data analytics course very effectively. Now we move on to the next one. And what are the attributes we are going to define for this big data characteristics? Generally, we are using huge volume of data to access the particular data centers in database. So it's not just in terabytes or gigabytes. You have to calculate in terms of a petabytes. Okay. Now that much big data, huge data we can able to analyze. That is one of the characteristics in your big data analytics. Second one, the complexity of data types and structures also take into place, that is variety of sources. For example, if we receive the climate data from satellite, then the satellite data is not going to be meant and it is not at all pre-organized or supervised data. Generally, the data is divided into two types. One is supervised, another one is unsupervised. Supervised means already the data is having a label for each and every column. Unsupervised means it doesn't have a label. So basically, based on the supervised and unsupervised distinguishes, we can able to select few algorithms. As per this particular volume and variety of this kind of data types, it actually comes under unsupervised data. Like I said earlier, that is climate data. So if you take any temperature or climate such kind of data from satellites directly, it's not exactly in proper format. So we have to analyze the data, definitely it should be in formatted type. So that is one of the characteristics in this particular big data, that is variety of data also we can able to analyze using big data analytics. That is one good advantage in this particular phase. Next characteristic, that is speed of the new data creation and growth. As usually, whenever we are going to take a particular data, obviously it should be grown day by day. That grown up data we have to organize and we have to analyze. That is the purpose of high velocity and rapid ingestion and fast analysis is needed in the real world. So all these are the different three types of characteristics we are going to define for this big data analytics. Next, sources of big data Delhi. So where we are going to use this particular data collection. One of the sources is mobile sensors. That's already said to you, that is GPS and accelerometers. From that kind of input, we can able to get this mobile sensors data, and social media and video surveillance and video rendering. So rendering means it will be used in animations. So rendering is going to be useful for your animations. So at the time also, we have to extract and analyze the video type of data from data centers with graphics card support. So that is the advantage of this video rendering. Next, smart grids and geophysical exploration, where the oil mines and refineries are available in the earth and where the gas refineries are available on the earth. All these particular kind of analysis first we have to do. So that is one of the advantage of geophysical exploration. Next, medical imaging. In medical field, we have a lot of huge type of data day by day the patients are going to be generated. That type of images and high resolution EMR or MRI scans, such kind of high resolution data also we can able to access using this medical imaging sources. Next, gene sequencing. I hope all are aware of it. The COVID-19 is having different variants. So how those variants are going to be identified by the scientists because of this genome sequencing. So genome sequencing is also play a vital role in nowadays. So these are the different kinds of sources to collect the data as a source of a big data. So the same thing I already mentioned in the previous slide. I already given just a glance in terms of a pictorial thumbnail representation. Now this is the example I took from this 23andme.com. So this is genotyping from already acquired the information from that image. So here the data is going to be collected in terms of a genome sequence. Data structures and characteristics. So already I told to you earlier two types, that is supervised and unsupervised. Again, the similar concept is going to be applicable in terms of a level of more structured architecture. So apart from this, so unstructured data at the bottom always. We are not yet finalized, we are not categorized data. The entire raw data will come under unstructured data. Next, on the top of the floor, we have quasi-structured data. Quasi-structured means 75% structured data. 75% is structured and remaining are unstructured. Next, semi-structured. 50% structured and 50% unstructured. Then structured. Structured means all 100% it's a structured data. So this is the actual flow from bottom to top. The structured modularity of each and every data is going to be keep on increasing. So this is one of the advantage of this types of characteristics of different types of big data. So generally we are talking about structured and unstructured data in this particular course. So data structures, characteristics of the big data, here we have four types. One is structured, semi-structured, quasi-structured and unstructured. All those four types already discussed just before 5 minutes. Now comes under structured data. Which type of data will comes under this structured type of data? One is transactional data, next OLAP and RDBMS as relational database management systems, and OLAP defines comes under mining. Next, data mining. Next, CVS files, comma value separated files and spreadsheets. All these things will come under structured data. Can I know why it is called as structured data? Because entire data is going to be labeled in terms of a column wise. That's why it's called as structured data. Semi-structured data means not 100%, 50% structured and 50% unstructured. Now coming to this semi-structured, here text data with discernible patterns. Example, XML data is comes under semi-structured. Only 50% of the data is structured and remaining 50% is not at all structured. Comes to the quasi-structured data, the text data with erratic data formats. Example like a clickstream data. Clickstream data is erratic. Why? Because it's not at all Sometimes I may click on some button, sometimes I may click on some other buttons in your website. So in order to collect a perfect data is not possible. That's why 70% unstructured and only 25% structured in quasi-structured data. Finally, we can come under unstructured data. So the data with no internet structures like text documents, PDFs, images and videos, everything will come under unstructured data. Take any kind of video or PDF, it's not in a proper format. Why? Because it's having some images, sometimes the PDFs having some text mixed with images, and sometimes you may get video links, and all those things are comes under unstructured data. So these are all the 4 types and examples where we can map this particular data. So this is the example of a structured data. If you see, each and every column is having its name. Example of semi-structured data. Here the data is having collection of images as well as some code and as well as some text. So this is called semi-structured type of data. Next, quasi-structured data. If you take any kind of search results from Google, it's not having all some images will be there and mixed with the text also will be there. So this is comes under quasi-structured data. See, you can see any kind of log files. For example, Windows is going to create some log files automatically whenever a software is going to be installed or uninstalled. So at that time, we are going to use this particular structured or semi-structured, this kind of quasi-structured data. If you take any kind of data like in terms of a quasi-structured data, will comes under URL as well as queries. Next, already I told you the unstructured data, which is purely related to the videos. Okay, video is obviously comes under unstructured data. So all these are different types and examples of this kind of data analytics. Now, I will just introduce about this, how in terms of a data repositories from an analyst perspective. Generally in big data, we have 3 kinds of jobs are available widely. One is data scientist, data analyst and data engineer. So what the data scientist will do? The data scientist will create some algorithms to analyze a data. And what the data engineer will do? The data engineer will write a program for that particular algorithms. They will develop the algorithms which is created by data scientist. What about the data analyst is over? Data analyst, what the data analyst will do? The data analyst will analyze the data by putting and applying these algorithms in a particular different types of data already announced to you. So this is the actual roles and responsibilities of the particular data science pattern related jobs. So here comes under data repositories. Spreadsheets and data marts will comes under first category, and the characteristics are spreadsheets and low volume databases for record keeping unless depends on data extracts. We can extract the information from spreadsheets in terms of different kinds of data marts. Data marts is nothing but a part of a data in your database. Next, data warehouses, where we have to store these particular data marts. We are going to store in a mass or bulky in data warehouse. Finally, analytics sandbox, that is our workspace. So here in workspace, we can able to assets gathered from multiple sources of data we can able to gather it, and we can able to enable some high performance data analytical capability machines. From that we can able to extract the leverage on database processing. So this thing is comes under analytics sandbox. These are the different data repositories that are available. Now we will move on to that session 3 and 4 in your CO1. Yeah. Here we are going to consider the key concepts, that is already I discussed about the big data overview just now, and the state of the practice in analytics. How we can able to use this particular big data analytics in real world scenario. Now generally we are compete always with the business intelligence. Obviously the big data analytics is going to be always compete with the business intelligence. So how these particular two things are going to be combined? So here the business intelligence like Power BI, Microsoft is introduced one software called Power BI. By using the Power BI tool, we can able to analyze data and we can generate some visualized reports as like your Excel. So that is the purpose of Microsoft Power BI. How it is going to be compared with data science. So current analytics architecture also I will tell in this session, and drivers of big data. Who will drive these particular big data? Next, emerging big data ecosystem and a new approach to analytics. These topics are going to discuss in this session. Now, these are the drivers who will run this particular business, big data business. So first person is optimize the business operations. And second one, identifying the business risk. Third one, predict new business opportunities. And fourth one, comply with laws or regulatory requirements. Generally, first of all, we discuss about what is meant by optimize business operations. For example, like sales and pricing and profitability, efficiency and marketing, whatever it calls, you can able to analyze and optimize the business problems generally we are facing. That is the actual purpose of this big data analytics. Second part comes under identifying the business risk, where the risk is available in the business. That thing also we have to confuse. That's why we have to identify first of all the business risk, then we can able to solve the problem. So that is the actual purpose of this big data analytics, second kind of business driver. So here customer churn and fraud detection and what you call everything which is faced by the business problems. So those problems are going to be solved by using this big data analytics. Fourth driver, predict new business opportunities. For example, I want to become an entrepreneur. Then definitely, first of all, I should know what is the exact scenario in current situation. For example, upcoming skills. Which skills are required to start a startup? Or which things are required? Which skills are required for my entrepreneurship? So that kind of analysis are going to be comes under this predicting the new business opportunities. Come to the fourth business driver, comply with the laws or regulatory requirements. So obviously we have anti-money laundering and fair lending based on SAFTness and OXI. All these things will come under comply with laws or regulatory. So everywhere we have to follow the laws. So how we can able to follow these laws and regulatory requirements? Those things are whether it is acceptable or not, whether these are applicable or not in the real world. That analysis is also going to be done by this big data analytics course. So all these four things are comes under a drivers for this big data analytics. So this is the reference. Now you can see data science is a overall outside the entire overall area. Then from that business intelligence is a subset. Now data science subset is a business intelligence. Now if you observe in the x-axis you have a time and y-axis you have a analytical approach in terms of a exploratory. So if you see already data science is overcoming this business intelligence. So obviously business intelligence is a subpart of the data science. So if you see, so typical techniques and data types are going to be used in data science and common questions, what it and why we have to go for this. So that is the actual common questions in the data science. If it comes under business intelligence, typical standard and ad hoc procedures are going to be used for this analyzing and visualizing the data in business intelligence. So here the structured data is going to be used in business intelligence. So that's why it is very easy to visualize the things. And what are the common questions generally we are using in business intelligence? How many units are going to be allotted? How many going to be added? So these things will come under business intelligence. So this is the big data analytics architecture, the typical analytic architecture. If you observe, first of all, I already collected the information from various data sources. Later, in terms of Excel sheets or in terms of reports. And the next procedure, this is going to be pre-processed data, not yet processed, it's a raw data. So these data is going to be again comes under to departmental warehouses or EDW. Okay. So here the analyst part coming to picture. So if you observe three people with logo is there with parts of analysts. So these analysts will going to collect the data from warehouse and they will analyze the data, whether it is a semi-structured or supervised or unsupervised or quasi-structured. So these people will going to analyze the data. Then it is going to be comes under EDW. It will be distributed in terms of a dashboards or reports or alerts. If in case of any data science users are required introduce any algorithms, then they will introduce. So that's why it is going to be a typical analytical architecture for your big data. Now here comes into picture, this is the sample example dashboard which is going to be useful for your big data users. So here if you observe, this beautiful dynamic dashboard is going to be created by using big data analytics software or big data using big data analytics techniques. So which is very useful. By seeing the particular icon itself, we can able to analyze the data without checking each and every row and column. That is the beauty of this dashboards. That's why most of the companies are asking for this dashboards. Next, coming to the picture, so this is also one of the dashboard related to that patient satisfaction dashboard. These two are already collected from existing source in internet. Now this is the current analytical architecture already explained earlier. So data sources must be well understood, and EDW represents enterprise data warehouse, and from the EDW data is read by applications. And data scientists get data from downstream analytics processing. So all these four parts are going to be putting together. We can able to get this architecture flow of big data. Next, coming to the picture, same thing I represented in terms of a pictorial representation and graphical manner. So here in 1990s, initially this is the first evolution of your big data. That is RDBMS and data warehouse is going to be generated from Oracle, and SAP is also one of the part of the particular generating a sample data in 1990s. Later in 2000, the content and digital asset management is going to be coming to picture. Now content is going to be stored in terms of a PowerPoint presentation, Word document, Excel sheets as well as PDF files. See, generally we can able to measure this particular data in terms of a petabytes. So after that again we have to go for this 2010. Now this is the before generation, 10 years back. We have 2010, we have YouTube and we have genome sequence, Wikipedia and whatnot, SMS, WhatsApp, Facebook, Twitter, lot of social media applications are going to be generating a huge data. That's why to maintain and analyze the data, we need definitely a big data analytics concept. So here in 2010, we introduced NoSQL and key value pair, that is your dictionaries concept, data structures. So based on that, we can able to come nowadays, big data analytics playing a vital role. Now this is the actual flow, how the data is going to be generated generation by generation. First of all, it started with terabytes. After that, it went to petabytes. Now it's related to exabytes. Later in future, we don't know what is which type of bytes will come into picture generally. Now these are the emerging big data ecosystem. This is the actual ecosystem and a new approach to the analytics. Four main groups of players are available here. First one is the data devices. Data devices means what everyone knows about smartphones, and we are going to be generate the data by using those particular devices, right? So example, games, online games, smartphones, computers, everything is going to generate the data. Next, data collectors. Who will collect the data? Phone and TV companies, internet and governments, whatnot, each and every organization are going to collect the data from different sources. Next, data aggregators. See, here we comes under websites, any credit bureaus and media archives. Those are comes under data aggregators. Aggregators means they will aggregate the data by collecting information from different sources. For example, I will tell you in given very easy example to understand. For example, you are going to apply for a home loan. Take in that example. For home loan, we have to extract the data first of all from the bank is going to extract the data from different sources. First of all, they need to verify your property documents, and second time they will verify your CIBIL score, whether you taken earlier any loans or not. So based on all these different factors from different sources, finally they will decide whether you are eligible for that loan or not. So this is what meant for the data aggregators. Finally, data users and buyers. Obviously, all the end users will come under data users and data buyers. Sometimes the data is going to be sold to some other person. For example, I'm a company, I'm having total consultants company, I'm having total 1,000 people data with phone numbers. I want to stop processing of, I want to close my company. Then immediately my company, the data, that users data may be useful for some other consultancy companies. So I will sold out the data to some other companies legally with some process. So that's why data users and buyers are comes under this fourth final of group of players. The same thing I represented in this pictorial manner. So what are the fields which are available and what are the fields we are using for these different types of data. Now, three key roles of new big data ecosystem. First role, deep analytical talent and data savvy professionals and technology and data enablers. Comes to the first role, that is a deep analytical talent. Not all the people are having analytical capability. So that's why data scientists only they can able to analyze the data and they can able to write some algorithms, they will be able to generate the algorithms. So that's why data scientists will come under that category, deep analytical talent. So generally this is the actual gap which is going to be in terms of a analyst or scientist in US. So these many people are required. 1,40,000 to 1,90,000 people are required as a data scientist jobs in US as per the statistics. Second comes under data savvy professionals. These professionals are not going to generate the algorithms, but they can able to use those algorithms. They can have a skill of use the particular algorithms. That is the actual purpose of this data savvy professionals. Even these particular jobs also 1.5 million people are required in US. So that is the gap in terms of a million, right? Like third point, that is technology and data enablers. Obviously, the data engineers will come into picture. They are just going to analyze the data and they will just distribute the reports in terms of a dashboards. So these are the three key roles, the new big data ecosystem. So as I said earlier, so these are the particular people. Deep analytical talent is going to be come into picture. The mathematics and statistics and machine learning, these kind of skills are required for a person to make it as a deep analytical talent. And data savvy professionals are having but less technical than group one. Those are not having that much technical knowledge, but they need to have some data analytical knowledge. So that is what by data savvy professionals. Technology and data enablers. These people will come under database administrators and programmers. Every people comes under they are touch with the technology will comes under this technology and data enablers category. So these are the three play major roles in the particular big data ecosystem. The same thing I represented in terms of a picture. So this is our pictorial representation of big data ecosystem. And here first of all services, integration and large analytics ISVs and specialized ISVs, big four, that is Facebook, Google, Apple and Amazon, databases and storage, infrastructure and network like data centers and hardware. So all these things all comes under big data ecosystem. So without having a data, there is no concept of analysis. First of all, to collect the data, these are the different types of sources. So again, three recurring data scientist activities. These are the activities which are going to be performed by data scientists. The first person is reframe business challenges as analytics challenges. Here, first of all, we need to reframe the challenges, whatever we are facing in the real world. Next, design, implement and deploy statistical models and data mining techniques on big data. Obviously, we have to prepare some data mining algorithms by using some statistical features. Next, develop insights that lead to actionable recommendations. Whatever we are going to prepare, the prepared data is going to be useful for those people are going to be useful for in terms of applications. So that's why those applications we have to develop by using this developing insights by technical people or programmers. Next, profile of data scientist. 5 main sets of skills are needed. That is, one is quantitative, second one curious and very creative, third one commutative and collaborative, and fourth one skeptical, fifth one is the technical. These are the 4 skills, 5 skills are majorly required for this data scientist. So these are the profile of data scientist, 5 main set of skills. One is quantitative skills. Already told you, mathematical minimum, mean, median, mode, standard deviation, all those such kind of minimum basics of fundamentals of statistics. That skill is required for this quantitative skill. Next, curious and creative. They should be passionate about the particular algorithms generation. Next, communicative and collaborative. Obviously, they should maintain the communication along with your people they are having a colleague, and again collaborative learning also needed. Collaborative learning means the teamwork also needed. So finally, skeptical mindset and critical thinking, ability to examine work critically. So they need to go in depth about the problem and they need to find a solution. That is very, very important in big data analytics. Next skill, that is technical aptitude, software engineering and programming, general core subjects of computer science, all those kinds of technical aptitude knowledge is required here. So these are the 5 main sets of skills required for a particular person. Next, examples of big data analytics. So retailer target, this is the actual examples, Apache Hadoop and social media companies like LinkedIn. LinkedIn is a very job making portal renowned in the world, that is LinkedIn. So LinkedIn also, they are going to use this kind of big data analytics for analyze which type of suitable jobs are available for the market. And Apache Hadoop, they are going to use MapReduce paradigm. That paradigm is used to analyze the data and to filter the data and pre-process the data very easily. So this is what the data visualization of users social network using in maps. Here, these are the entire world is going to be, data is going to be widely spread and it is used, it's just a small pictorial representation. So this is what the summary of this particular session. Mainly I focused these particular points of this particular course, that is focus on mathematics, statistics, machine learning, providing the overview of big data analytics and in-depth study of several key algorithms we are going to discuss in the next session. Yeah, coming to that session 3 and CO1. Now this is related to that data analytics life cycle. So every architecture or every technology having its own ecosystem and its life cycle. Now this is the big data analytics life cycle. I will show you. Yeah, these are the phases which are involved in this big data life cycle. The first phase is the discovery. Second phase is data preparation. Third one, model planning, model building, communicate results and operationalize. So all these phases, if you see by name itself, you can able to analyze which phase is doing what. First of all, come to that phase 1, that is the discovery phase. In this discovery phase, first of all, we need to discover the data where we have to collect. That is what the purpose of this particular phase. So it will comes under first phase, discovery phase. Second one, data preparation. How we have to collect the data, it is taken care of by discovery. And what we have to collect the data and which type of data we have to collect, that will comes under data preparation. If the data is having any missing values or if the data is having a noise data or it's having any outlier, those particular data is going to be processed using this data preparation phase. Data pre-processing is comes under this data preparation phase. Next, phase 3, model planning. After preparing the data, pre-processing is over, I need to process the data. For that I need a model. For build a model, that is the next phase. Here I need to plan the model in third phase. Which type of model is suitable for my data? That is model planning. Then later, if it is confined, it is mapped to the data perfectly, then I need to build that model by writing some activation functions or by writing some code. So that is what the model building. Finally, communicate results. After my completion, I need to go for my post processing of data. That post processing means how we have to represent the data in terms of a dashboard. That is what communicate the results in terms of a dashboard. Finally, we comes to that operationalized phase. What is meant by this operationalized phase? For example, I created a software, but I am not able to use it by the users until unless I deploy it in a cloud or deploy it in a website. So that phase becomes under operationalized phase. Even in terms of an operationalized phase, in case of any problems the user is facing, that feedback is going to be collected back, and that is going to be again organized and resent to that model planning. So this is what about the data analytics lifecycle. I took just a Gina case study as an example. I will show you what's what in the upcoming videos. So this is the data analytics lifecycle overview. We have 6 phases already told to you, and the cycle is iterative to portray a real project. Any project using big data analytics should follow these 6 phases. See, key roles for a successful analytics project. The first one is a business user. He is a general user. And second one is a project sponsor. The who will funding the project is called a project sponsor. Project manager will manage the project by organizing the code, and it is going to be connected with always with a project sponsor. Later, business intelligence analyst is going to analyze which type of algorithms are useful for this make a project work it out. Later, it is going to come under data scientist. He is going to prepare some algorithms which are suitable to analyze the data. Later, data engineer will write a code for that particular data algorithms, and he is going to finally send back to database administrator. So database administrator is going to be having a grip in your data set finally. So the database, a data set is going to be again done by the database administrator. So these are all the different roles are going to participate in order to complete a project. So this is the key roles for a successful analytics project. I hope you got it. So the same thing I represented in terms of a bulleting point. So business user is going to understand the domain area, and project sponsor is going to provide the requirements, software requirements. Next, project manager is going to ensure conducting a meetings with the client, and business intelligence analyst will analyze which type of an algorithm is used for here, and database administrator will always create a database environment, and data engineer is going to having a with the technical skills, he is going to create algorithms which is generated by the data scientist. And finally, data scientist to provide analytic techniques and modeling also done by the data scientist. So these are the different types of roles are used in big data analytics project to complete. So these are the different kinds of data analytics life cycle. We have different aspects. One is scientific method, general method, and delta framework, and these are all different kinds of models and different kinds of networks we can use in this particular data analytics life cycle. This is the background analysis we are going to done by this big data analytics. And one of the tool we are using widely for statistics, that is a magnetic agile deep data analysis, that is MAD. So generally this particular MAD mechanism are going to be deep agile. Agile methodology is going to be compiled with a normal methodology. Agile means when a particular problem is coming to picture from customer side or client side, we can stop the process then and there itself, and we can modify it, and later we can able to solve the problem and continue the process. That is the advantage in agile methodology. But earlier days we are not having agile methodology. After completion of the project, then only the client will give some modifications. Those modifications is going to be again done by, it will take lot of time and lot of manpower waste, money waste, and time waste. So to overcome this problem, we are using this agile types of methodology. So phase by phase, we have to again, same information is monitored by the client, and he can tell some suggestions, and modifications will be done then and there itself. Now again we have to go for this deep thinking and deep analysis of data is going to come into picture, and magnetic means it will attract the data sources and it will extract the data from different sources. So these are the 3 types of information which is going to collected by the big data analytics professionals. Now this is cross-industry standard process for data mining. Now here the data understand data preparation and modeling execution. If in case of any problem in execution, again it will go back to business understanding, and finally there is no problem in evaluation, then go for this deployment. So this is what the complete cross-industry standard process for data mining, that is CRISP-DM. It's called as CRISP-DM. Next framework I already told you, that is Davenport's Delta framework. This is one framework which is related to the data enterprise leadership targets and analysts. Why it is called as a Delta? Because it is having all its own features, which is going to be start with the starting letter Delta. So it is represented in terms of a triangle. This is one of the framework. Next, this is applied information economics approach. So if you see, it looks like a flow chart. First of all, I need to have a 5-step process is there, and here also we are going to use this applied information. We are going to add it as a compute. Finally, it is going to come and it will going to be feedback to the as a bar is going to be connected to the second one. Next one, this is the overview of data analytics life cycle. First of all, in discovery phase, what is the actual purpose of this? Do I have enough information to draft an analytic plan and share for peer review? If it is there, then I can go with this discovery. Again, after completion of that, that same data is going to be prepared. So here also I have a question. Do I have enough good quality data to start building the model? If it is there, then it will go for this model planning. Otherwise, it is going to be refining. Then from model planning, do I have a good idea about the type of model to try? Can I refine the analytics space? If in case, then you have to go for this model building. In model building also you have a question, is the model robust enough? Have we failed for sure? If it is there, then you have to go for that communicate results. Without having a failure, then if you go for communicate results. If you have a problem with this model building, then again go back to the model planning and refine the solutions, then come back to the model building. Finally, from communication results, it will move to the operationalize phase. So this is what the entire big data analytics life cycle overview. I hope these particular same thing I explained, I covered earlier. And finally, we are going to perform some types of operations, that is ETL/T transformation. So here extract, transform, load and transform. So ETL, first of all we need to extract the information from different sources and we have to transform it, and finally we have to load the data into dashboards. So that is what the ETL. So learning about the data and sample data set inventory. So this is what here, first of all, the data available and accessibility is there or not. First we have to check with the data sets, that is products shipped. Finally, product financials, that is data available but not accessible, and product call center data also available but not accessible, and live product feedback surveys we can able to data to collect. We can collect the live data, live feed data, and product sentiment from social media also will comes under data to obtain from third party sources. We have to collect this data. So from this data inventory we have to collect the raw data. Next, data conditioning. Obviously the data conditioning also plays a vital role, whether a data is having any missed values or not, any junk data is there or not. First of all we need to remove it, and finally we have to keep the data in condition mode. So how to clean the data when terms of a data conditioning, how we can able to clean the data, and what are the data sources and target fields are available, and how consistent are the contents and files missing or inconsistent values or not, we have to identify, and assess the consistency of the data types, numeric or alphanumeric we have to identify, and review the contents to ensure the data makes sense, whether it is the suitable data for my requirement or not we have to analyze, and look for evidence of systematic error. Any data related error is there, we have to first check it out. So these all parameters we have to check in terms of a data conditioning. And finally, the survey and visualize the data will comes under this particular phase. So generally, if you have any filter, if you want any filter data or any other types of analysis, we can able to perform by using the survey and visualize the data. Why we need data visualization more? Because a picture worth 10,000 words. So that's why instead of telling these many number of sentences like this, if I show a picture to you, it is very easily it will reach your mind. So that's why the visualization plays a vital role. data visualization is plays a vital role rather than seeing a normal raw data table with your naked eye. That is the difference with data visualization also. So these are the common tools for data preparation. One is Hadoop can perform parallel ingest and analysis, and Alpine Miner is also one of the good tools for data mining activities. And OpenRefine is going to be called as a Google Refine also. It's a free open source tool for working with messy data. Messy data means huge data. Next, similar to OpenRefine, Data Wrangler is an interactive tool for data cleaning and transformation. Already I told you, for data cleaning purpose, to remove the missing values, to replace the gaps, and everything is going to be done by the Data Wrangler software. So these are the different kinds of information related to that life cycle of your big data analytics. With this, we can conclude this particular session 3-4 in big data analytics. Now here we move on to the last session for my particular CO1, that is your model planning. Already told to you how the models are going to be planned. See here, these are the activities to consider to plan a model. First of all, we have to assess the structure of the data. This dictates the tools and analytics techniques for the next phase. First of all, we have to assess the data in this phase. Next, ensure the analytic techniques enable the team to meet the business objectives or not, we have to identify. Third point, determine if the situation warrants a single model or a series of techniques. Here, single model is enough or series and mixed of hybrid models are required or not, we have to check once. Next, research and understand how other analysts are approach this kind of similar kind of problem. The literature survey definitely is required in any way. We have to perform any research. Already what the other people already done their research in the earlier same field for to solve the problem. That thing also we have to consider. So that is my last point in my model planning. Next, in model planning generally we have to go for market sector, how the consumer is packaged the goods, and retail banking by using multiple regression, and retail business will comes under logistic regression and decision tree types of algorithms, and wireless telecom services they are using neural network decision tree, hierarchical, neuro fuzzy logic systems, rule evolver, and logistic regression. So these are the models are available, are used by existing domains in different types. So I hope you clear this about how the industry people are analyzing the data in different domains by using different kinds of analytics algorithms. Next, data exploration and variable selection. How we have to explore the data and how we can able to select with the data is variables are properly segregated or not. For example, in a table, I have total 100 columns of a data, but out of 100 columns, I don't want all the columns as for analysis purpose. I need to pick only two columns based on the correlation and based on the covariance. These two things are statistical parameters are used for me to pick those two important columns around out of 100 columns. So that's what is going to variable selection is going to be playing a vital role in this particular kind of model planning. Next, after that planning, we have to select the model. We are going to select the model by using R tool, SAS, MATLAB, different kinds of tools are available for selecting different kinds of models. First of all, you have to know that which type of model is suitable to solve your real-time problem. That is what the major important information related here. Next, common tools we are using, one is R and SQL Analytics Services and SAS or Access. These are the three major softwares we are using to model the planning, different kinds of model planning phases. Next, coming to that model building. This is my fourth phase. So in model building, we are going to define the phase 3 in terms of different kinds of questions. One question, first important question, that is, model appear valid and accurate on the test data or not. Take any kind of data. For example, I want to analyze the data. then definitely I need to split the data into three parts. One is train data, test data, and validate data. So among those three types of data, whether my model is accurate or not, we have to test it out based on the test data. For example, I have 100% data. In the data, I have only 40% is there as a training data, and remaining 20% as a test data. Remaining 40% I have to make it for a validate data. So that is up to you. So if you want to split the data, after splitting it, you have to analyze each and everything based on the existing model. Next point, does the model output behavior make sense to the domain experts? So domain experts need to think whether it is suitable for that or not. Next, do the parameter values make sense in the context of the domain? Whether the right parameters we are taking for the domain to build a model or not, we have to consider. Next, is the model sufficiently accurate to meet the goal? Whether it is good accurate model or not, we have to check the accuracy. Does the model avoid intolerable mistakes? We have to check. Are more data or inputs are needed? We have to gather. Will the kind of model chosen support the runtime environment? Yes, we have to check. Is a different form of the model required to address a business problem? We have to identify. So these are the different kinds of questions we have to make ourselves. We have to ask ourselves in order to start for building a model. So these are the common tools for model building phase. So commercial tools are SAS Enterprise Miner, SPSS Modeler. IBM is going to introduce this one, and MATLAB and Alpine Miner and Statistica and Mathematica and Informatica. These are the tools are used for commercial purposes, and for open source tools are also available for this model building. One is R, Octave, Weka tool, Python and SQL. All these are open source tools to prepare a model or build a model. Then we are going to the next phase, that is communicate the results. So in communicate results, we have determined if the team succeeded or failed in the objectives or not. First we have to determine, and if the team is failed, we have to search where the particular team is, why the particular team is failed. Again we have to go back and rethink, and we have to communicate again. Next, assess if the results are statistically significant and valid or not. We have to analyze in terms of a communicate results. So before communicating the results, first we have to check whether errors are there or not. Next, identify surprising results and those in line with the hypothesis. Whether my particular result is satisfied and it's followed and mapped to the hypothesis or not. Hypothesis is nothing but it's a statement. Next, communicate and document the key findings and major insights derived from the analysis. This is the most visible portion of the process to the outside stakeholders and sponsors. So that's why whatever the background process you run, that is not a matter. But finally the stakeholder or a customer or a client, he will see the final dashboard. So whatever the work, hard work you prepared in the background, he don't want. Only he need finally the end result, whether it is coming up to the mark or not. So that's why we have to communicate the results by using that point. The last phase, that is your operationalize phase. In operationalize phase, we have to deploy the particular data by using all these particular roles. So all these people is going to work it out to deploy the data. Here database administrator role is there, and data engineer role is there, and data scientist role is there by preparing the models in terms of a PPTs. And finally the data integration analyst also, they are going to create some PowerPoint presentations, and project sponsor will ask a few questions about how the particular type of requirement he wants. So that is what also prepared by PPT, and business user also create some PPT. So different types of data is going to be required to complete a final end of a project. So that's what about the operationalize phase. Here these are the key outputs from successful analyst project. So business user, project sponsor and project manager, and business intelligence analyst, data engineer and data scientist. These are all the different kinds of people are involved in this particular make a project a successful project. So these are the four main deliverables are needed for this operationalize phase. One is the presentation for project sponsors. High level takeaways of executive and level stakeholders are very, very essential. And second one, presentation for analysts. Describe business process changes and reporting changes. We have to give some presentations in terms of a PowerPoint. Next, code for technical people, also taken care by code scientists. Next, technical specifications of implementing the code also we have to mention in terms of a document. That is software specification. document. In that, we are going to mention which type of information is required for this operationalized phase. Now, finally, I will close this particular entire life cycle for CO1, that is based on this case study already mentioned, that is Global Innovation Network and Analysis. That is, I took as a GINA project as a case study. In this, we have to search different kinds of patterns and insights about it. I will show you phase by phase how the particular case study is going to be applicable, and it's followed the ecosystem of life cycle of your big data. First, the team members and roles. These are the BI analysts, big data analytics are required, business users are required, data engineers and DBS people are required, and data scientists also required. So these are the major skills people are required for this particular case study in phase 1. Next, so here the data is going to be fell into 2 categories. So 5 years of idea submissions from internal innovation content, and minutes and meetings and minutes and notes representing also is going to be categorized. Then hypothesis grouped into 2 categories. Hypothesis, here we are going to first consider the descriptive analysis of what is happening to spark further creativity. So what is the existing one we have to face, that is there under descriptive analytics. Predictive means what we are going to predict finally as the outcome based on this analysis. That is what your predictive analysis data. Next, we are moving to next phase, that is data preparation. In data preparation, we are going to set up one analytical sandbox, and from the sandbox, people are discover the data based on the data conditioning, and entire data is going to be conditioned and augmented and cleaned and pre-processed in this particular data preparation phase. And they discovered many names were misspelled and problems with extra spaces. We need to remove all the data and clean the data, and we have to condition the data in this particular data preparation phase. Next, we will move on to the data model, that is model planning. In model planning, we have to identify the right milestones to achieve the goal, and trace how people move ideas from each milestone toward the goal, and track ideas that drive the others reach the goal. That is also important. And finally, we have to compare the times and outcomes using a few different methods. And finally, from model planning, we have to move on to model building. In model building, we are going to use some NLP and textual types of descriptions, and using a statistical features like R and RStudio. And finally, we are going to develop some graphs related to the social media types of visualization techniques. And from model building, we are having formed this kind of graphs. We have formed 5 clusters here. Like by seeing the particular visualized image itself, we can able to identify and categorize the data, and finally we can build the model. So finally, we are move on to that communicate results. In communicate results, we have to follow 2 things. One is study was successful, found high density of innovators are there or not. First of all, you need to communicate the results in terms of a visualized graphs. And last phase, that is operationalized phase. Finally, whatever the module you prepared, that module you are going to deploy it in terms of a business intelligence software help. So for that, you are using Microsoft Power BI. You can take support of any kind of business intelligence software. You can finally get the visualized data clear. Now, this is a summary about all these particular phases, and based on the data analytics life cycle, total 6 phases are explained with example as a case study. Now, with this, I can complete the first CO1 in your big data analytics. So, I'll meet you again in CO2 in big data analytics next time. Thank you.